Today we're going to be talking about section 9.2. The title is multiplying and factoring. As we're going to learn today, multiplying and factoring are the opposite processes of each other. And the first thing we're going to be doing is multiplying a monomial and a trinomial. Remember, a monomial means one term. Examples of monomials: 3x, 4x squared, 7x to the fifth. Anything that's connected together with multiplication but just as one term. A trinomial, remember, is something that has three terms. Say we added all these three together. So we're going to be multiplying a single monomial times a trinomial. Now, a couple things I put as a note here. When you multiply powers with the same base, you can apply the distributive property and then you add the exponents on the variables. Remember, though, still to multiply the numbers themselves, the coefficients being 3, 4, and 7. So we're going to distribute first the front multiplier to each part in the parentheses. So here we go. Here's our first one. 4a is our monomial times 5a squared minus a plus 3. If it helps, I don't know if you want to do this or not, but you might want to think, okay, that's really a minus 1a in there. And now we're going to multiply 4a times 5a squared, 4a times minus 1a, and 4a times positive 3. So here we go. 4a times 5a squared. On this first one, I'm just going to write it out. Plus 4a times negative 1a plus 4a times 3. Now the reason I'm writing this out is just so we can see the actual process of multiplying and distributing. 4 times 5 is 20. A times a squared is a cubed. We add a to the first and a to the second. Then 4 times negative 1 is negative 4. And a times a is a squared. And then lastly, 4 times 3 is 12, and a is left by itself. And so that's our answer. Now, just as a reminder, we want to make sure we leave our answers in standard form. Standard form has the exponents decreasing. All right? Let's look over at number 2. We're going to multiply negative 3x squared times x cubed, negative 3x squared times 2x, and negative 3x squared times negative 8. So I'm going to write this out. Negative 3x squared times x cubed. Negative 3x squared times 2x. And negative 3x squared times negative 8. Negative 3 times 1 is negative 3. X squared times x cubed, we add the exponents, x to the fifth. Negative 3 times 2 is negative 6. X squared times x to the first is x cubed. And negative 3 times negative 8 is positive 24 x squared. So in both cases, we've written our answers in decreasing degree for our problem. So when you're distributing, make sure you multiply it out times each part, then pay attention to your positives and your negatives to get your answer. Let's move down and look at our part 2. Part 2 talks about finding the greatest common factor. The greatest common factor is a common idea that you have before, but today we're going to work with it with regards to also having variables. In our first part, we're looking at the greatest common factor of these three terms: 6y cubed, 20y squared, and 12y. Now, some of you may have thought about greatest common factors just in terms of numbers. We want the largest number that goes into both. Depends how you approach this. Sometimes I'll approach this in this manner, and I'm going to factor out these numbers. 2 times 3 times y times y times y. 20 is 2 times 2 times 5 times y times y. Now, if you've forgotten how to factor 20, that's 4 and a 5, and 2, 2, and a 5. To factor the 12, that's 4 and a 3, that's 2, 2, and 3. So 12 is 2 times 2 times 3 times y. Now I'm going to circle the factors that are in common with each one. So they all have 1, 2. They don't all have a 3, and they don't all have a 5, and they all have at least one y. So my GCF, my greatest common factor, is 2y. Here's our next one. 5x to the fifth and 10x cubed. The factors of 5 are just 5 with 5 x's. The factors of 10 are 2 and 5 with 3 x's. What's in common with both? They both have a 5 and they both have 3 x's. So my GCF is 5x cubed. As we continue to look at these, we want to just kind of work through it and say, what is our GCS of each one? Between 10, 20, and 30. Can you think of the largest number that goes into each one? Hopefully, you realize that's 10. Now we have between a cubed, a to the 5th, and no a's. Well, because there's no a's on the bottom one, the GCF still is just 10. All right? So that ends our part 1 as we kind of work through our problems here. Let's flip over our paper and let's look at part 2. It says, to blank a polynomial is the reverse of multiplying. So on the first page we were multiplying and finding the GCF. GCF stands for greatest common factor. Okay? So the word we're looking to write in here is the word factoring. And we're going to be doing a lot of factoring in this chapter as we try to break down polynomials into simpler forms. So to factor, we first find the greatest common factor, and we pull that greatest common factor out of the term. So let me demonstrate what we do here. More practice on finding the GCF. Between 6a squared and negative 8a. Here we have 6. We're going to break that down to 3 and 2. Here we have 8. That breaks down into 2, 2, and 2. So I've got a GCF between these two of 2 times 3 times a, and 2 times 2 times 2 times a. There's my 6a squared, and there's my 8. Common factors are a 2 and a single a. So 2a is my GCF. And now I'm going to actually do the factoring procedure. I write my 2a out front and put a large parentheses behind the 2a. And now I say, what's left of this first 2a squared? When I take out the 2a, what was left? A 3a. So 2a times 3a is 6a squared. So we're kind of doing the multiplication backwards. Then I look down here. What's left when I took out the 2a? Well, a 2 and a 2. So I put a 4 back there. Now I have to pay attention to my signs. 2a times 4 is not 8a. 2a, though, times negative 4 is my 8a. So my GCF is 2a, and my factored form is 2a times the quantity 3a minus 4. Let's continue. Our next one, as we look at it, is 18x cubed minus 6x squared plus 12x. We're going to have to break down each one of these. And so here we have our 18x cubed. 18, if you can think of it, is 9 times 2. So that's 3 times 3 times 2 with 3 x's. 6 is 2 times 3. So we're going to have 2 times 3 with 2 x's. And 12x is 4 times 3. That's 2 times 2 times 3. So 2 times 2 times 3 times x. So here are my factored forms. What do they all have in common? They all have 1, 2. And they all have 1, 3. And they all have 1x. So my GCF is 6x. Now you may be able to see these 6x or 2a quicker than writing out your factor trees. But if you want to write our factor trees, do that to the right, and then we'll do our factoring on the left. If you can do that, that's perfectly fine to make that jump. The danger is if you don't find the greatest common factor, you may end up with just with a 3x or a 2x and not the 6x. But in this case, we do have the greatest common factor of 6x. So I write that out front. And I leave space for a trinomial at the back half. I look at my first one, which was 18, and what didn't I circle? A 3 and an x and an x. So that's 3x squared. I look at my second one, and what didn't I circle? Just 1x. And I look at my third one, what didn't I circle? Just a 2. Now I need to put in the right signs. 6x times positive 3x is 18x cubed. 6x times negative x is negative 6x squared, and 6x times what is 12x? A positive 2. You'll notice the signs follow what the signs are directly above there. So this is called our factored form. This is our GCF. All right, our last one. 15n to the fourth minus 3n cubed plus 12n. First, we'll start with the 15. 15n to the fourth. That's 3 times 5 times 4 n's. 3n cubed. That's a 3 times 3 n's. And 12n squared. That's 2 times 2 times 3 times 2 n's. So here we have it broken down into the smallest possible factors. Take a minute right now and identify what the GCF is. All right, that should probably be enough time. Let's do it together. They all have a 3 in common. No other numbers. And then they all have 2 n's. So the GCF, hopefully you put down, was 3n squared. Now we look at our problem. We put our 3n squared out front. Put our parentheses in the back. Remember, your parentheses need to have the space for a trinomial. Look over at our GCFs. What's left? 5n squared. What's left here? Just 1n. So that's minus 1n. And then down here, just plus 4. The reason this is a minus is that's a minus right there. The reason that's a plus is that's a plus right there. Now, as you improve on this, you're going to be able to avoid having to do this. But right now, I would suggest strongly you write out your factor trees, and then it will allow you to factor very easily on these problems. All right, so that kind of ends our lesson. Our homework, as we're looking at it, we have a 2-part homework because we have a quiz on Thursday. The first part of your homework is the normal homework on page 463. I want you to start with that. The second part of your homework is the practice quiz, 9.1 through 9.2. And that quiz is going to be on Wednesday. At this point, I want you to flip over, and let's look at this bottom part down here. If you remember from Friday, 13 squared. I want you to look over to the sideboard, and you'll see 13 squared is 169 over on your left. Now, if you know 13 squared, and you can remember that, remember 3 times 3 was a 9, and 3 plus 3 is a 6, 14 squared is easy. All I want you to do is reverse the 6 and the 9, and you get 196 for 14 squared. So that's 14 squared. So at this point, everyone flip your page over, and let's look at the next page. And we're going to have a little race again. And we're going to race and see who is the first person who can do the top 14 numbers. So draw a line between 14 and 15. Don't start, but draw a line between those two. You're going to, as fast as you can, write the first 14 squares, and when you finish those, you're going to stand up. And the first 3 people will get M&Ms. So, everybody get your pencils out, put them in the first square. Don't start yet. Okay, on the count of 3. 1, 2, 3, go.